So previously on the Finance Fundamentals channel, I made a couple of videos which on the face of it are not related to each other, but in fact in both of those videos I used exactly the same 1,000 share stock exchange setup to illustrate the points I was trying to make. See the links below if you'd like to watch those videos later on. The imaginary setup in those previous videos that is turning out to be so surprisingly useful that I use again in this video is of an imaginary 1,000 share stock exchange in which a credit event occurs for 50 companies each year. By credit event, we mean some kind of debt default. If 50 companies have a default, that means that 950 companies do not. And I show those proportions of the exchange in red and green. Then we set up a hypothetical in which we have a machine learning classifier which has some ability to predict a default by a company on this stock exchange. The classifier is binary in the sense that its output is either a yes, the company will default, or no, it will not. And finally, we complete the setup of our imaginary model by indicating that in cases where the model predicts a default, in other words, its answer is yes, it is 90% accurate. And in cases where the model predicts that there will be no default, it happens to be 85% accurate. So back to our exchange with its 50 defaulting companies and 950 non-defaulting companies. We set up our model to assume that it is 90% accurate in terms of its ability to correctly identify the defaulting companies. This means that the model correctly identifies 45 out of the 50 defaulting companies, but misses 5 of those defaulters. Turning attention to the model's ability to correctly predict the non-defaulting companies, here we have assumed that the model has an 85% ability to correctly predict the non-defaulting cases. So given that we have 950 non-defaulting companies, this means that 808 non-defaulters are correctly identified, but 142 non-defaulting companies are wrongly tagged by the model as being at risk. Now we can use the confusion matrix from the previous video as a systematic way to organize the analysis that we have in a graphical form at this point. Let's begin by tidying up and rearranging that confusion matrix just to make some room for the numbers from our example. So we have 45 true positives in the sense that these are actual defaulting companies correctly identified by the model. Next, we have 5 false negatives, and these are actually defaulting companies which the model has failed to identify. And for the actual positive, which is the actual defaulting company, we have, as expected, a column total of 50. Then, moving on to the negative column, where we have non-defaulting companies, we have the false positives, which are 142 companies which the model incorrectly tags as being at risk when in fact they are non-defaulting companies. And the true negatives at the bottom right, there are 808 of those, and those are companies which are not defaulting, and the model has correctly identified them as such. As expected, once again, the column total for the negatives, which are the actual non-defaulting companies, is 950. Then we have the rows. The first of them is the positive. In other words, the test here has said yes, these are defaulting companies. There are 187 companies which have rightly or wrongly been identified by the model as being defaulting companies. And then the second row, the negatives, these are the 813 companies which, once again, rightly or wrongly, have been identified by the model as being predicted to be not at risk. And then in the bottom right-hand corner, we have confirmation that our calculations so far appear to be correct, with our total observations adding up to 1,000, which is the same as the number of shares on our imaginary stock exchange. We can now use the numbers we have allocated to the various quadrants of our confusion matrix to calculate the key metrics used in the evaluation of the performance of our imaginary machine learning classifier model. So we are, I think at this stage, with the video carrying on a little bit long, we are going to just do a mechanistic calculation of sensitivity, specificity, precision, the false positive rate, accuracy, and the F1 score. And I will add brief explanatory annotations to each of those without trying to suggest that that is enough to explain each of those somewhat bewildering range of different terms. And with that somewhat busy slide, I think that's a very good place to end this video. Future videos, I'll be looking at how those metrics work, how they should be interpreted, what situations you should be using them in, and how to work with them. But for now, I think that's more than enough for this video, and thank you very much for watching, and I will see you in the next one.